Hey everyone, thanks for joining us today. In this video, I'm going to be talking to you about forces and more specifically explaining to you what is a force or what a force is if I was to say it with proper grammar. Anyway, a force is really simple. It's basically any sort of push or pull on an object. And that's it. That's the whole thing behind a force. Anything that's pushing or pulling on an object is a force. I guess that's the end of the video. No, I'm just kidding. I'm going to talk a little bit about some nuances of forces and maybe give you a few examples of forces as well. So, stick around. There are two main types of forces, and the first type of force is a contact force. Now, a contact force can be friction, air resistance, spring, tension, normal force, centripetal force, or applied force. Basically, any of these forces require physical touching between two objects. So if you were to talk about friction, that's two surfaces rubbing against each other. Air resistance is air coming in contact with something and slowing it down. A spring is, the stretchy things that, go in and out. But those require physical touching to compress them or extend them. Tension requires contact between something, and tension comes from ropes and strings and cables. Whenever you pull this rope and it gets really tight, there's tension in that rope. Now, normal force, centripetal force, and applied force. I want to talk a little bit about those in detail in a future video, but the normal force in basic terms is the surface pushing back on an object. Centripetal force is any force that makes an object move in a circle. And applied force is just a generic term that I like to use for any sort of pushing or pulling that might be happening. So those are all contact forces. They require some sort of physical touching. The other type of force is non-contact force, and these are kind of spooky and mysterious and hard to wrap your head around sometimes. We use gravity, magnetic force, and electrical force. Now, these are all forces that act over a distance. And Isaac Newton was the guy that discovered that gravity acted over a distance, and it can act over a very large distance. I made a whole video about gravity. I'll probably put a link to it somewhere on the screen here for you to watch. But these forces act over a distance, and as they get closer, their force increases. Think about it as a magnet. You can feel the attraction or repulsion between magnets. If you put the North Pole and North Pole next to each other, they're going to repel. If you put the North and South, they're going to attract, and you can physically feel the force between them. And electrical forces are very similar to magnetic forces. If you have a positive charge and a negative charge, they're going to attract towards each other. If you have a positive and a positive, they're going to repel. But those are all non-contact forces. Now, I want to talk with you about balanced forces. This is when all the forces on an object are balanced. And I want to do a little bit of an example. Let's talk about a table and a Coke can. So we'll have a table here, and we will put a Coke can sitting on top of the table. Okay, I'm going to say cola. Let's make this table look better. Okay, so that seems to be a little bit better. Anyway, it doesn't matter. Whenever a Coke can is sitting on the table, you know that there's going to be some sort of force of gravity pulling it down. So we got force of gravity pulling it down. And then the normal force is the surface pushing back up on this Coke can. So we have a normal force that's equal and opposite, and it's pushing upwards. So this is the normal force. So in this situation, the forces are balanced. And whenever forces are balanced, no change will happen in an object's motion. So a Coke can sitting on the table, it's just going to sit there. And the reason why it's sitting there is because all the forces around it are balanced. Now let's do a different example, maybe something that's a little bit more complicated. And you notice that this says there will be no change in the object's motion, which could imply that an object could be moving. So let's get a car driving down a road. There's the body, wheels. Okay, so here's our beautiful car that I've drawn for us. And we're going to have our force of gravity going downwards, and we're going to have our normal force going upwards that's equal and opposite. Now this car is going to be applying a force forward. So there's going to be some sort of force applied, and that could be from the engine. So I'm going to call it force app for force applied. Now, whenever the car is driving down the road, there's going to be a lot of different forces acting against it. One of them will be the force of friction. So let's make that a little bit smaller. So we got force of friction. And then we'll probably also have a force of air resistance. Let's make that a little bit smaller than the friction. So force of air resistance. Now, I want to make these the same length. So if I combine the force of friction and the force, there we go, let's these the same so we know that we are talking. Okay. So we got force of friction and force of air resistance pushing the car backwards, and then there's a force applied from the engine pushing it forwards. So in this situation, all the forces are balanced. Now this could mean that the car is moving. So the velocity of this car is greater than 0 meters per second. So the car is moving forward, but all the forces are balanced. And as long as the forces stay balanced, that car is going to continue moving forward. There's going to be no change in its motion. So this is like a car driving down the road on cruise control. The engine is applying a force forward, and the friction from the road and the air resistance is applying a force backwards. All the forces are balanced, and therefore there's going to be no change in the car's motion. So in these two examples, we have one on the left here where there is no change in the object's motion because it's not moving. And over here, there is no change in the object's motion, but it is still moving. And these are two examples of balanced forces. So if all the forces are balanced, you're either going to have a velocity of 0 meters per second, or you're going to have some sort of constant velocity. So that's balanced forces. But now let's talk about unbalanced forces. Now, unbalanced forces are when things get really interesting. And let's just read through this. Unbalanced forces are the reason objects start moving. They're the reason objects stop moving. They can be the reason an object will speed up or slow down, or even be the reason an object changes direction. Now you may be wondering what this picture is I have here, and this picture is what I like to call space brick. It is a brick that is floating in space. Now let's start off and let's do a few examples with space brick here, and we're going to say that the velocity of this brick is 0 meters per second, so it's just sitting there. And over here is a very small meteorite that I would have just kind of space debris floating around. Now, right now, this brick has no force on it. It is just floating out in the middle of space. There's no force of gravity. There's nothing acting on it. It's just there, existing. And this little piece of space debris comes and hits the space brick on this side. Well, that space debris is now an outside force. So now the forces on the space brick are not balanced, and that will give the space brick a little bit of motion. So an unbalanced force came in and started the object in motion and gave it a little bit of velocity. Now let's take this space brick and let's say it is actually moving. It's no longer just sitting there. It has a velocity in this direction right here. So it's moving to the right. Now, if this little piece of space debris is coming and it crashes into the front of the brick, well, that's going to either slow the brick down, it's going to make the brick stop altogether, or it's going to change the direction of the brick to go backwards. So if there's a head-on collision between the space brick and this piece of space debris, a lot of different things can happen. Now let's say that the space debris actually comes from the top and crashes into it from the top side. Well, if it comes and crashes into it from the top, then the velocity is going to change to maybe some direction like this. So this piece of space debris is our outside force, and it's crashing into the space brick in all these different directions. And as it's crashing into the space brick, it can either make it start moving, it could either make it stop moving, it can either speed it up, slow it down, or change its direction. And this piece of space debris is basically our outside unbalanced force. So anyway, I hope that helps explain to you what a force is and kind of some nuances behind it. Stick around, I'm going to be talking about Newton's laws in my next video.